Welcome to Brain Vision.
Problem 784 is about the stretching of the DNA string. So we have the stage moves at constant speed while stretching the DNA. You can read more about this in the text. And which of the graphs in figure 784 best represents the power supplied to stage versus time? Okay, so we need to figure out how to relate power to time. So one way to do that is to consider the work that is being done. So power, we know, is the amount of work done in time, in amount of time. Okay, so we need to relate this to some of our equations we know for Hooke's law, one of which is the F equals kx. So we need to relate work to force somehow in order to get further. So we need to change work to some kind of thing with force. And we do know that work is the product of force times displacement. So we have the stage, it moves straight in a straight line. The displacement is in that same direction, so we can simplify it like this. So we can write that as force times displacement divided by time. And we'll notice is when we have a displacement over time, we immediately turn that into a velocity. And so we can interpret this velocity as the velocity that is constant speed that the stage stretches the DNA. So now we know that that velocity is going to be constant, but how does that force change? So we're trying to find the power as some function of time, but how does that force change? So we can then substitute in what our force is for this right here. So we'll see now that the stage, as it moves, it's going to the force is going to increase linearly with the distance that it's moved. And so that means that the power is going to increase linearly with the distance or time that it's moved.